In this Kubernetes and CKAD tips number 14, we will talk about creating simple service using kubectl expose command. But before that, let us first understand some basic stuff about service. So to understand service, think of Kubernetes as a loosely coupled set of things, right? So for example, if you have a pod or a deployment, under deployment you will have pod, they are deployed in multiple different nodes. Imagine that's node 1 and this is node 2, okay? And then you have got pods running containers, okay? And then you are controlling the whole thing using something called deployments. So what happens when, and each of these pods gets an IP address. So, and then because deployment dynamically creates these pods, these IP address quite frequently changes. Now, if you have something like a front end, and then backend service, and if the front end is talking to the backend, you need to have some mechanism to identify what is the IP address that front end is going to talk to. And if that IP address is frequently changing, it becomes difficult. So what we do is that we use a concept of a load balancer called service. So service is, think of it as a load balancer. And then when somebody uh, lands into the service, and then if you say that I want to expose this deployment as a service, then it will redirect your traffic to either of these two pods if they are doing the similar stuff, right? So if you have created, let's say, two replicas, so two pods will be created under the deployment, you will be pointing them like that. Now, this service or the Kubernetes service uses something like cluster IP. So cluster IP, you can think of it like a local IP address, right, which you get. And what happens when you use this mode, the kube proxy, that agent, watches the Kubernetes control plane for the addition and removal of the service and endpoint objects. Each of the service, it installs an IP tables rules, which captures the traffic to the service's cluster IP and port and redirects that to one of the service's backend sets. For each endpoint object, it installs IP table rules, which select a backend pod. Right? So this uses the internal uh, Linux configuration, and which is kind of like net filter, we call it, and it's quite reliable, right? And then this is by default. And let's see how it happens in a real scenario. So if we, let's say, assume that we create a deployment, let's do that over here, right? So let me go into my demo machine, and this time I am using my AKS cluster. That's the Kubernetes running in Azure, which is fully managed. And what I'm going to do is that I'm going to create a deployment. So I'll say k create deploy, and I say nginx, and I give the image nginx. I say replicas 2. So what this will do, it will create a deployment, and then it will create two pods against that deployment. If you say k get pods, you will see two pods. If you say k get all, you will see pods deployment replica set. So far, so good, right? So it doesn't really have any services created. So this service is the default service. So I haven't created any service. So what happens, this pods, if you say k get pods, this pod gets some IP address by default. So if you want to see what is that IP address, you say void, you do that void display of the pod, you will get to see that internal IP addresses being assigned to these pods. So I have got 10.244.0.6, 10.244.1.6. These are the internal two IP addresses. The moment I kill one of the pods and I get another pod, I probably get another random internal IP address. Now, how do I make sure that there is a load balancer sitting on top of these two pods and then redirecting my traffic, and I point to that load balancer irrespective of whatever happens, whatever time it creates the pod to. Now, one of the things Kubernetes does is that it also creates a pod to the node or the individual machines based on the capacity available, right? So if you, let's say, have 5 nodes, the first 2 pod may be getting created in the first node, but it might so happen that it switched to the some other node and then get some other IP address. So it's not always the fixed IP address you might get from the pod perspective. So having a load balancer really makes a lot of sense. To do that, we have a kubectl expose. So I'll say expose. And then if you don't you want to see what exactly it talks about, all right? So let me just reduce the font size. And if you go on top, you will find some examples. So it can expose a pod, it can expose a deployment, etc. So it can basically expose pod, service, replica controller, deployment, and replica set. If you see that I want to expose the deployment, right? So to do that, I basically say expose deployment, right? You notice here this example, and it says that it's going to go ahead and deploy my deployment to the port 80, right? And the target port is 8000. So if I take this whole thing, right? Just copy the whole thing and I just paste it over here and just run it as is. So what happens, there is a new service which will get created. You can see service nginx got created. If I say get SVC, that's a short form of service, you'll get to see 2 services. One is the nginx. That's my service, which is just now created 8 seconds ago. And the IP address is 10.0.247.24, which is kind of like known as cluster IP, right? So it is the IP address of the cluster, right? That's the default behavior. So when you create the service, you could also specify the type of the service. So if now the best thing about this is that these are loosely coupled. Now if I delete the service, it won't delete the deployment and its corresponding pods. So I don't have to literally change my pod design to enable that as a load balanced service. So I can create service the way I may want to create. So for example, if I create another service, okay, against the same deployment, I use this and I say that this is, let's say, 2. And then I can mention something like dash dash type equals to node port. If I say so, it creates, so that's the name of my service, dash name equals to nginx2. Okay, so that will create one more service. So if we now do the service exposure, you find a second service against the same deployment, right? And then it gives you a different port type, node port. A node port is accessible from all the pods in different nodes, right? So you can think of it like distributed, but still this is not accessible from outside. So you can create one pod again in the same Kubernetes cluster and try to access the service using the IP address. Possible. But if you have to expose it to the external world, right, you need to do something. You need to do things like ingress controller, or if it's in the cloud, you can use load balancer. So imagine that my service now is in cloud. So I give the name of the service like this. I say number three. Okay, number three is cloud, just to make sure that it is cloud clearly visible. And this time, I'm not going to use the node port. Rather, I will say that I want a load balancer. Okay. If I do that, now you notice here that each of the services I created before, that is cluster IP, node port, doesn't have an external IP address. Okay. However, if I say get SVC, you see that now I have a external IP address. And this is a public IP address, by the way. So you can even use this IP address to do get into that. So if I say wget dash o dash and http colon this one. So there is no host but connecting to. So hopefully I can open a browser. So let me try doing that. Get into a browser and I say that this is the browser and I just try to open that browser. You can see over here in the screen that I'm trying to open that IP address. If my pods and everything is fine, it will ideally be showing the Nginx homepage, right? That's coming from within the pod I have created, right? So you can see that there is some issue with that, but let me just stop this and let me see what is the port it is using. It is using 31744. So if I do come over here, use that port, should get me. So the whole idea is that you build a service for somebody to use. If it is, let's say, internal system, then use internal IP address. If it is external system, use the external IP address. But you need to actually open it up, right? And that opening it up requires you to do this service creation. Now, what I wanted to quickly also show you is that how the service definition looks like, right? So if I say get Nginx load balancer cloud, and then I say oh YAML, it will show you the YAML file, the generated YAML file, which basically holds the definition of the service. But I did not mention the service type. So let's say SVC, SVC space, and then the name of the service, which will give you the output like this. Now you can see that it has a target port 8000, port is 80, right? This is the specification of the service, and the cluster IP is this one, right? And then you have got a load balancer ingress, right? Controller, which has got a public IP address available, right? And then it basically fetches the deployment using selector, right? That's the app nginx. That's the level. So my deployment has got a level called app selector, and that's how it is connecting. That's the glue. So that's why level is so important, that if you change the level of your deployment, now this service won't be able to identify your deployment anymore. If you have to uh, onboard a deployment, you can add the level over here in a service. And if you delete that service, it doesn't delete the related deployment because they are not master child kind of relationship, right? So they do not have that tightly coupled kind of thing. So it doesn't really matter. So they are quite flexible. And you have seen that I have created three services, right? Cluster IP, node port, and load balancer against the same one deployment, right? And this still works, right? So which means that it is now able to. Now, one of the quick things I wanted to also talk about is that get EP. There's endpoint. And you can see that because I have two pods, right? Basically, a replica set for the deployment was two. I always get two endpoints for each of the pods. So I can use these endpoints to internally connect to, right? So for example, the Kubernetes comes with this endpoint. The Nginx cloud comes with this endpoint, this endpoint. So these are the endpoints which basically points me to the actual pod which is behind this load balancer or the service, right? So that's how I'm able to connect to. So if I increase the number of, let's say, replicas for my deployment, if I say k edit deploy nginx, and then I change that replicas to, let's say, 4, 4, and then I come out of this, and if it accepts that, and if I run this get ep, definitely there will be 4 pods created, and you will find 4 endpoints, right? So because I increase the replicas, so hence endpoints are increasing. So that's how they're monitoring things. So k I can do k delete sbc nginx nginx2, and it will delete both the services, right? And it only the service, which is the load balancer service, will be available. And you can see that I still have the deployment running in my local machine. So it did not delete my deployment. So they are loosely coupled. So it was a bit longer, but it is an important topic, and it can go very deep based on the requirement. So I do recommend that you refer to the documentation about services, the official documentation, which talks in detail about the service and what you can do that. And remember one thing, that for application, designing the service is the key component. So you have to be very, very comfortable knowing what exactly you are doing and how you can expose things. That concept is really, really important. Hope you have enjoyed, and thank you very much.